I'm Dominic Hodgson and we are here on the West Antarctic ice sheet at the Lake Ellsworth drilling site. We have two sediment corers here at Lake Ellsworth which we're going to deploy to collect sediment from the bottom of the lake. One is a gravity corer and the other is a percussion corer. The gravity corer is simply a hollow tube with a very heavy weight on the top of it, and the aim is that just through its own mass it will drive that hollow tube into the sediment, and we can then retrieve that sediment to the surface. The other corer is designed for a much stiffer sediment, and it has a percussion hammer, so we lower it to the sediment surface, and then the percussion hammer hammers it down into the sediment, and hopefully will get us a longer sediment core doing that. Now, we don't know which of those corers is going to be most appropriate to use in this environment until the initial probe has gone down. And using the video camera on the probe and watching the small sediment corer we have on the tip of the probe, we should be able to make a good decision about which sediment corer is the right one to use in this environment. We know very little about the sediments in this lake. All our information comes from geophysical surveys that were carried out a couple of years ago, and they showed us what looks like a layered sediment accumulated at the bottom of this lake. This is very exciting for us, because what layered sediment often tells us is that sediment has accumulated year on year on year, and so is essentially provides us with a historical record of what's happened progressively going back in the past. The history of the ice sheet here is absolutely critical. The ice sheet stretches more than 500 kilometres in that direction, and more than 1,000 kilometres in directions either side to the east and to the north here. It's more than 3 kilometres thick. This is a vast ice sheet. But we know that this is also an ice sheet that is grounded well below sea level, and it's one of the ice sheets that could melt if temperatures rise around the globe. What that would mean is the sediment beneath our feet here in the lake would turn from being a sediment deposited in a subglacial environment to a sediment deposited in a marine environment, so just in the open sea. If that has happened at this site, what we expect to see is the remains of microscopic marine organisms that live in the world's oceans. These have got resistant cell walls. They will sink into the sediment and be very well preserved. If we find evidence of that, then we will know that this ice sheet in this location has melted in the past. We will hopefully know what the age of that melting event was, and we can say how sensitive the ice sheet is to even a moderate degree of warming. We are interested in life in these environments because they would tell us about the limits at which life is viable on this planet. This planet evolved initially in a very icy state, and that is very similar to some of the environments we find on other planets in our solar system. If we can understand life at its most simplest, in its most simplest conditions, we will understand much more about life on Earth itself and how it evolved.